In this video, we're going to show you an example where we start with a new part and we create the vector data that we're going to cut using the design tools in the software. Here we've just got some simple rectangles and some text that we're going to create. Then we're going to check our material setup and calculate a pocket toolpath to cut away the area between the inner border and the text, and a profile toolpath in order to cut the part out. Finally, we'll show you how to preview this to check that everything looks correct and create an image like you can see on the screen here. And once you're happy with that, how to actually save that file in a format that your CNC will understand. Let's start with a new copy of the software. Let's start by clicking on the icon to create a new file. And the work area for this particular job is going to be 7.5 inches in X, or 7.5 inches wide, 3 inches high, or 3 inches in Y if you want to think of it that way. Material Z0 is going to be on the top of the block, and the thickness of our material is 1/4 inch, or 0.25. Now we're going to work with the datum in the centre of the job, at least for the design stage of this. So XY0 currently is set to the centre, as you can see here and in the 2D view, and as I mentioned, we're working in inches. Let's go ahead and hit the OK button, and that'll take us into the main interface of the software. The first shape that I want to draw is going to be a rectangle, so I'm going to click on the icon here under Create Vectors to draw rectangle. I'm going to set the anchor point of the shape to be in the centre at X0, Y0, which, as we've just set up, is the middle of our job. I'm going to do radius to external corners, so I would like there to be a round shape on the corners there, or a fillet, which is another word often used in CAD drawing software. And the radius for that is going to be 0.15 of an inch. Size of my rectangle is going to be 6.8 by 2.4, and I'm going to hit the Create button so we can see there's our rectangle with the rounded corners. Now I want to create another rectangle, this time that has internal or an external radius of 0.05 of an inch on the corners, and the size of this is going to be 6.5 by 2.1, and hit Create and close there. So now we've created two rectangles that represent the border of our nameplate. Now we can create our text, so we'll click on the icon to draw text, and in here I want to type the text Avalon, which is the name of our model train engine that we're making this nameplate for. The font I'm going to use is going to be a true type font, so make sure that's checked. I'm going to click the down arrow and I'm going to hit A on the keyboard to go up to the fonts beginning with A. And from there I'm going to choose Arial or Arial. I'm not sure of the pronunciation there, but you should be able to find that on your PC. It's a pretty standard font. Not going to check bold or italic. Text alignment is going to be in the center. Text height is going to be 1.3 inches. Anchor X0, Y0, and we'll hit Apply and Close. Now you can see that's positioned the bottom of the text in the center, which is what we told it to do there, but I would like that to be located in the middle of my part. So with that vector text selected, I'm going to click on the icon here to align selected vector. I'm going to choose the option at the top here, which will align that both centrally, horizontally and vertically within the part, and come down and hit Close. And that simple set of vectors is all we need for our design, and we're ready at this stage to start calculating the toolpaths to cut it. So we can come up to the icon here under 2D View Control, switch to Toolpaths tab, and when we click on that it will minimize the Drawing tab on the left and open the Toolpath tab on the right and fix it in place. The first thing we want to do before we calculate any toolpaths is to double check our material setup. If we click on the Set button here, we can come in and confirm the values that we entered before. So Z0, top of the block, thickness of material 1/4 inch. My XY0 is currently set for the middle of the job, and I could certainly proceed in that way and just make sure that that's where I indicated to the CNC machine that XY0 would be. Or if I prefer, I could change that at this stage before we calculate a toolpath. So I'm going to choose the lower left corner option, and now when I set up the job on the CNC I can just tell it that XY0 is in the lower left corner here. The rapid gaps and the home position need to be set to appropriate values so that when the tool lifts out the material to move to a new position, it'll clear any clamping that you have in place. So these values need to be high enough to get above whatever your hold down method is, and the home position is just the position the tool is going to start or move to before it starts cutting a toolpath. Once I'm OK with everything in there, we can click on the OK button. And now we're ready to choose the type of toolpath we want to use to machine the job. In this case, we're going to have a couple of different toolpaths. What I want to do is first machine away the material in between this vector and the text. So I need to select all the vectors involved in this cutting operation. To do that, I'm going to select this vector by clicking on it, hold the Shift button down on the keyboard and click and select the text. The text is just a single entity at this stage, so I only need to click on that once in order to select all of it. So this should appear as a solid purple line, the rectangle should appear as a dashed purple line, and now I've got my vectors selected and I'm ready to choose the type of toolpath that I'd like to use to cut them. In this case, I want to machine in between these down to a given depth to pocket out that area. So I'm going to come up and click on the icon here for the pocket toolpath. In this case, I only want to use the simple version of the pocket toolpath. I don't want the advanced options, so I'm going to uncheck that here. At any time to get those advanced options back, we could just recheck the box there and the software would display them to us. Now the start depth is going to be 0, which is the surface of the material, and the cut depth for this toolpath is just going to go down to a value of 0.1 of an inch below the surface. So I'm going to enter cut depth 0.1. Next, we need to choose the tool that we're going to use to machine this. If I come down and click on the select button, that will open the tool database. This displays the library of tools that we have available and can be edited and configured so that it represents the set of tools that you own, and even setting up different parameters for different materials and applications. In this case, I'm going to select an 1/8 inch end mill, quite a small end mill, because I need it to get into the corners of my letters and make sure that I get enough detail. I can change the parameters in the tool database if I want, but they'll be remembered the next time I come and choose this tool. So sometimes I may not want to change it here, but I may want to just hit apply and OK and come into the tool selection area and click on the edit button instead. In this case, this allows me to edit these parameters, but just for the purposes of this particular toolpath. So here, if we were cutting this into relatively hard material, I may want to change the pass depth to be quite small there. I may want to reduce the step over to say 20% of the tool diameter and reduce things like our feed and plunge rate. Now in reality, you need to make sure that you choose values that are appropriate for your machine, material and tooling that you have available if you plan to actually cut this. These are just example settings. With those, I'm going to hit OK, and that's our tool selected that we're going to use to machine this. Next, I need to tell the software how we want to clear out the area that we're cutting between. So we can choose to offset, that follows the shape of the vectors, or raster, which will go back and forward in this sort of lace pattern and then profile around the outside if we want it to. In this case, I'm going to choose the offset, and then we just need to choose whether we're climb milling or conventional milling as we cut this. Finally, we have the option, if we want to reduce the loading on the tool, to ramp it in, which means it will enter the material diagonally rather than vertically downwards. Some tools don't have a particularly good cutting face as they're entering material vertically, so it can help them to add some horizontal movement to that as well. Here we'll check that and put in a value of 1/2 inch ramps for this. Now I can give the toolpath a name, and I'm just going to enter some information that helps me identify the tool that I've chosen for this particular toolpath. The name of the toolpath is something that's totally subjective, and you should just use something that works for you to understand it and help you organize as you create toolpaths within a part. If I'm content with that, we can hit the calculate button, and there in the 2D view, or rather it's automatically opened the 3D view for us, and it's showing us what that toolpath looks like in the 3D view. So if I rotate this around, we can see the toolpath based on the settings we've entered there. Also, the software's automatically opened the preview toolpaths form as well, after we hit that calculate button. Now, as I mentioned, within the 3D view we can see the actual path the tool is going to follow when this part's machined. The red shows its rapid position as it moves from location to location above the material. The light blue shows it ramping down into the part. The green shows retract, so as it's pulling up vertically, and the dark blue is the actual feed rate cutting moves. Now, while it's handy to sort of see that displayed to us, it's much more useful to see what the finished part is going to look like after it's been cut. And we can do that using the Preview Toolpath option. First, we can choose the material we want to use to shade this. In this case, I'm going to come down to the metals and choose Steel Bright. Next, we can choose if we want to colour the area that we machine. I'm going to go for a global fill colour, and we'll choose a sort of dark green colour for this. We'll leave Animate and Draw tool selected, which will slow down the preview, but it will allow you to see the tool as it cuts the virtual piece of material. If we uncheck both of those, it would just do it much quicker. So now we can click Preview Selected Toolpath, and you can watch as the software animates what the tool is going to do as it pockets out those different areas and what the part will look like after that toolpath is complete. We can rotate this around in 3D, we can check it, zoom in, get it into different views. We can even save a copy of the image of this if we wanted to send that to a customer, potentially for them to approve. Now, the main thing for me at this point is just to check that I've got the level of detail that I'm looking for with the size of tool that I've chosen, and that it can fit into all the gaps that I have between my letters. So at this stage I'm really pleased with the way that looks, and I'm ready to continue to calculate the next toolpath, which will cut the part out. To do that, I'm going to close the Preview Toolpaths form, and I need to come over into the 2D view. So I'm going to come over and click here where it says New, which will take us back into the 2D view. I can just click in the background to deselect the vectors we currently have selected, and then click on the outer rectangle to select that. That's the vector that I need to cut out in order to cut out the part. Now we can go back over to the Toolpaths tab, and this time I don't want to pocket that, I want to profile around it in order to machine out the shape of our rectangle. So let's click on the icon there. For this toolpath, we're going to start at the surface of the material again, so start depth 0, cut depth needs to be the thickness of the block. Now I can either enter that numerical value, or a nice shortcut way to remember it is to type Z and then hit equals on the keyboard, and when we hit the equals sign, the software will reference the Z value, which is the thickness of our block. So it's just picked that value up and entered it for me, 1/4 of an inch, as you can see there. Next, we can select our tool from the tool database. I'm going to choose the 1/8 mm. This time I'm just going to take the default settings for that, so we don't need to edit it. I want to cut outside of the selected vector here, so make sure that option is checked. Choose the appropriate direction for our material and the tooling. Next, we've got the option again to ramp in if we want, so I'll check that option there. And also here we have the option to add tabs to the toolpath. What the tabs do is leave little pieces of material holding the part so it's still connected to the original block, and that just stops the part moving as we cut it out. If we have another hold down method where the part we're cutting is taped down, or we have a vacuum or something like that, then we may not need to use the tabs. In this case, we'll imagine that we do have to leave the part connected to the original stock, so I'm going to check the box to add tabs to toolpath. We'll add tabs in this case that are 0.15 of an inch in length, and the thickness for these will just make 0.08. Now I'm going to give this a toolpath name which is appropriate to my naming convention, and I can hit the calculate button. We'll see there that the software's warned me that I've told it to add tabs to the toolpath, but I haven't actually told it where these tabs are going to be. So that's given me a warning. Now I can hit OK, and at this stage I could go ahead and preview that, but it's already told me that I haven't added those tabs. So if we just close that, and with that toolpath selected I click on the icon here to edit it, we can come back in, click on the edit tabs button, and now it opens the toolpath tabs form, and in this case I'm just going to do a constant number 4 and click on the add tabs button, and you can see where it's positioned those in the job. Now it may be they're not exactly where I want them to be, so I can just click in order to move them around to a new position, I can also just click on any one of these and let go in order to delete it. It's possible to click anywhere to add a new tab as well. Once I like the position of those, I'm going to hit close. Now we can hit the calculate button again. This time we don't get any warnings because we've told it we're going to add tabs, and we've actually gone ahead and told the software the position or the location of where they're going to be added. Again, we can see the toolpath drawn in the 3D view, but we also have the option now to preview this. So with that selected, I can click preview selected toolpath. There we're seeing that machine around there, and you can see in the gaps tabs at the position where I asked the software to add them. So this is how the part's going to be held in place as it's cut out. Once finished, I'd need to take the material off and manually remove those. Once the preview's complete, if you don't see anything that you need to change, then you're ready to save the toolpath in a format that your CNC will understand. If you do see something that isn't right, then at this stage you should go back and make the appropriate changes, either to your vectors or to the toolpath settings or the tooling that you've chosen to cut it. Here I like the way this looks, so I'm going to close the preview, and now I want to select the toolpaths in order to save them out into a format our CNC will understand. So I can choose the first toolpath in the list here, click on the icon to save the toolpath. If I make sure both boxes are unchecked at the top here, then it will just save one toolpath at a time. I come down and choose the appropriate post-processor, and this is the file that's going to dictate the format that this toolpath is converted into, and I need to pick the appropriate one for my machine or the control that I'm using. So perhaps if I was running Mach 3, which is a popular one, I could hit M on the keyboard to go to where the list of processors are that begin with M, and from there I could choose the Mach 3 post that was appropriate for my control software. Again, just very important to understand, you need to choose the one from there that matches your particular machine type or the control software that you're running. Once you have that, you could hit Save Toolpaths, give it a name, and that file that you've saved is what you'd actually transfer over to your CNC machine to cut. In this case, I'm not going to save the file, I'm just going to hit Cancel, and I'll show you one other option we've got, and that's the fact that in this case, I have two toolpaths being cut with the same tool. So if I wanted to, I can actually save them into a single file. To do that, I would check the boxes for the visibility of both these toolpaths, and then I would come up and check the option to output all visible toolpaths to one file. The software will check that they are the same tool geometry, and if they are, it will present them in a list to me here, and now if I was to save this, it would go ahead and output both of those into a single file in the order that I see them in the list here. So when I ran it on the machine, I'd only have one file to run, it would pocket first, and then it would do the profile, cutting the complete job in one single file. So that's just a different option there if you've got toolpaths that use the same tool. Let's close this now, and the last thing I want to do is save a copy of the file itself so that I have something that I could open if I wanted to make changes or edits to this at a later date. To do that, we're going to come up to File, Save As, and in here we'll call this AvalonNameplate _toolpath, and go ahead and hit Save so we have a copy of that in the project folder. And that almost concludes this tutorial. What we've looked at here is how you can start with a blank job. We've done our design using the vector creation tools in the software, so in this case just a couple of simple rectangles and some text. Then we've come over to the toolpath side of things, we've double checked our material setup, and then we've gone ahead and calculated a pocket toolpath to machine out a 2D area between the inner border and the text itself, and then we've calculated a profile toolpath in order to cut the part out, and as you saw there, adding the tabs to hold the job in place. Finally, when we were happy with the way it looked based on the preview, we were able to save the toolpaths in a format that we'd be able to transfer onto our CNC and actually cut the part that you can see here. Now this is a longer version of this tutorial where we've gone into more detail explaining the different steps. There is a much shorter version of this where we show you just how quick it would be to go through this process without all the explanation. That concludes this video. Thanks for watching.